Today we're talking about two-step inequalities. Two-step inequalities. And inequalities, that's, the less than or greater than. Something to keep in mind is that we reverse the arrow. Reverse arrow if you multiply or divide. If you multiply or divide both sides by a negative number. If you multiply or divide both sides by a negative number. Okay, now we have that in mind. Let's go to number 1. Two-step problem. This is just like all the others we've done, except it just has an inequality. So my first step is to get rid of the plus 7. So I simply subtract 7 on both sides. 29 minus 7, that's 22. And do I switch the arrow? That's only if you multiply both sides by negative or divide both sides. I did not do that. The arrow just stays the same. To get rid of the 2, I'll divide by 2. And 2 goes into 22 11 times. Do I need to reverse the arrow? All I did is divide by 2, positive number. No, you don't have to switch the arrow. That answer is okay. Okay, second example. Okay, my first step is to get rid of the minus 1, so I'll add 1. Again, these are just two-step problems. You could multiply by 2, everything by 2, and to get rid of this 2. Okay, so this is gone. That gives us negative 1/2 x. And 3 and 1 makes 4. Do I need to switch the arrow? All I did was add 1. No, I don't have to switch the arrow. Next, I have a fraction here. I can just use a reciprocal to get rid of it, which is 2 over negative 1. All right, so all of this stuff cancels out here and leaves you with just the letter x. On the other side, 4 times 2 is 8, and there's 1 negative. Hey, now wait a minute. We multiplied both sides by a negative, right? 2 over negative 1. We multiplied both sides by a negative. Therefore, we need to reverse the arrow. Third example. Okay, so my first step is to get rid of the plus 3. And do its opposite. That's 0, so that gives me 4x. Negative 21 and negative 23. But they're both negative. I'll just add them up because they're both the same sign. Negatives don't cancel unless you're multiplying or dividing. So this is 24. And now what about the arrow? Do I need to switch the arrow? All I did is subtract 3. No, I don't need to do that. Okay, next I'll divide by 4 to get rid of this 4. And so that's gone. That leaves me with x. 24 divided by 4 is 6, and there's one negative. Hey, now wait a minute. I'm dividing by a negative, dividing with a negative number, but you know what? I'm not doing it to both sides. Do I reverse the arrow? No, I don't reverse the arrow. See, I multiplied by 4 on both sides. I didn't divided by 4. I did not divide by negative 4. Therefore, the arrow stays the same. We'll do one last example. Last example. So I first want to get rid of minus 57, so I will add 57. So that leaves me with negative 8x. And I have 57 minus 25. 57 minus 25 is 32. Now I added 57. Do I switch the arrow if I add 57 to both sides? No, the arrow stays the same. Next, to get rid of the negative 8, I'll divide by negative 8. Okay, I divided both sides by a negative. Do I switch the arrow? Yes, you do. Let's see, 8 goes into 32, 4, and there's one negative. And there's your answer. Now, hopefully you notice that anything with a negative coefficient, like negative 1/2 x or negative 8, then you're going to switch the arrow if you have a negative coefficient. If you have a positive coefficient, it's not going to happen.